So here it is. If you're watching this video, undoubtedly you are interested in the 1/14 scale 3D printed 825K model that I'm about to show you here. This video, the purpose of this video is to give you an idea of what's required to build it. I'm actually going to do this a little bit backwards. I'm going to show you a few features of the model now as built. It's all put together. It's a little dirty. I just went and drove it in the dirt, made some videos of that. If you haven't seen them, check that out. I've got about a 10-minute long video of it driving through the dirt. Purpose of this video though is to cover the construction. It's going to show you how it's put together, kind of the steps involved. I'm actually going to take this apart right after this, lay out all the pieces, and then we'll go through pretty much step by step putting it together. Very basic build, nothing particularly exotic as far as techniques or parts or materials. Nothing real crazy that you need to buy. It's all pretty easily accessible stuff. That was one of the plans. No exotic tires like my 637 scraper has. Nothing that's really hard for anyone to obtain. It's parts that are pretty easy to get either on AliExpress or Amazon if you're in the United States like me. And other than that, it's parts that are printed and pretty common off-the-shelf RC parts, so nothing too crazy. Just a couple things to get out of the way as far as techniques and kind of my thought process as I designed this, and my way of thinking when you design something and put it together is that everything should fit. Things should really only fit one way if possible. Again, I've tried to do a lot of work, a lot of iteration, whole huge bucket over here full of scrap parts that have been wasted because I have printed and redone and iterated until things hopefully fit together really nicely for you. If you have a good dialed in printer, modern printer, these parts should all print pretty easily. They'll be imported into your slicer in the orientation that is intended for printing. Obviously you can decide to deviate from that if you want, but all of these parts should print very well for you really, and it should go together without too much hassle. As far as tools go, you don't need anything particularly exotic. If you have a nice selection of hex drivers, that's going to be helpful. There are a couple spots in the model where there was no way around it. A ball driver is really the only way to go because of some of the angles. So if you have a 2 and a 2.5 millimeter ball driver, that'll really help you out in about 2 situations. And then obviously if you're going to use self-tapping screws, and this thing has a lot of screws, it might be helpful to use a small driver with some nice hex bits. So if you have those, not a necessity, kind of a luxury, but it would be nice to have some good hex drivers for your little small low power driver drill too. That would be helpful when you get to putting the screws in the bottom side. There's nearly 100 of them, so that would be helpful. Speaking of screws, I've tried to keep them all hidden. I really don't love exposed screws on a model, so with the exception of these button-headed cap screws on the blade and on the cylinders and that hold the blade arms on, and then the little tiny lights that hold the screws to the mount, you won't really see any exposed hardware. I've tried to hide everything underneath and make it so that it's not very visible. So that's just one of the techniques I like to use as I decide something. You don't need anything particularly exotic electronics wise for this. This is set up as a 6-channel setup. So we've got beacon as a channel, lights as a channel. Obviously you could just have those be on all the time, or you can omit them altogether if you don't want them. This model incorporates a vaporizer for smoke, so it uses an ultrasonic vaporizer to make simulated white smoke. That's certainly optional. You don't have to add that if you don't want to, so that would be a 3rd channel. Then we've got the blade, linear actuator, so a small ESC controlling that. A 35 kilogram servo for steering would be the 5th channel, and then last but not least we've got the drive. So in this model I used 2 ESCs, one for the front pair of motors and one for the rear pair of motors. I find that works well to put motors in parallel on an ESC. Some people are opposed to that. You may want to use 4 of them if that's your preference, or if you're really brave, you could probably put all 4 motors on one beefy ESC and not have too many problems. Again, personal preference, but you'll just need one channel output for that for the throttle. Initially when I was developing it, I attempted to use differential steering. I found that it was actually of no benefit and really in the end made the model harder to drive. So I've gone back to the tried and true beefy Metal Gear servo, to provide steering, and you won't need any fancy tank tread mixing, no differential steering, nothing exotic like that. In the video, the model is built with 90 RPM drive motors. It is a little on the quick side. Obviously I could drive it slower, but in the demo video I drove it pretty much full speed. Several people noted right away, hey, it looks a little bit quick. Because of that, I'll also list in the bill of materials a variant for a 50 RPM motor. It's probably a better choice if you are wanting to work in a more realistic scale-like manner in a fairly small area. If you work in a big area and have to traverse in between, maybe the faster motors are right for you. Maybe you want to be able to scoot right along in between jobs. The real machine will go 11 miles an hour or about 17 kilometers per hour when it's in its travel gear. So it's not a slow machine, but obviously when it's working, probably not rumbling along at 11 miles an hour when you're working. Just a couple other things to show you here before we tear it apart. Just a couple highlights, I guess, if you will. I don't like things that break, so I have made the handrails and the mirrors magnetic. All of these are held on with 3x2 millimeter magnets that are inset into the prints. So if you want to haul your model, you want to put it in a case, you want to take it somewhere, it's going to be a whole lot easier because these handrails all come off. Also, obviously, as a side benefit, if you bump into it, or your buddy's not very good at running an excavator, bashes into you, maybe rather than breaking your railing, he just knocks it off. So kind of something I'm proud of. The exhaust is held on the same way. It's held on with magnets, and then this rear cover, make sure that it's unwired here. We've got wiring running to the ultrasonic humidifier. We'll talk about that more in the build, but hatch is held on with some little magnets here and just sits down in grooves. I've incorporated a battery tray that is perfectly sized for a 5000 or the slightly longer 5200 milliamp hour battery. Can't have a 3S battery, I should say. Can't have a battery that's any thicker because there's only a couple millimeters clearance between this and the reservoir for the water for the ultrasonic humidifier that sits above it. But 5000 or 5200 fits in here nicely. I've incorporated a built-in panel mount XT60 connector, so one-handed battery changes are super easy. Got a master power switch that kills everything, and then I'm a big believer in fuses, or in this case resettable circuit breakers. So this is just a resettable 20 amp DC circuit breaker. If anything crazy happens, this will trip before you let the magic smoke out of everything and melt your model. So definitely incorporate some kind of fuse, or I think even better, a resettable circuit breaker. They're only like $3 a piece. Super easy to get. I'll have links for all this stuff in the description. All right, I think that's it for overview. Brief break here while I spend some considerable time off camera taking this all apart, laying out all the parts and screws, and then we'll get back and we'll go through the steps that are required to assemble it. I may not take every single thing apart, and a couple pieces of this are glued together, so I'll just do my best throughout the video to describe what's going on there. If I've got two pieces glued together, I will note that so that you'll know what's going on and know what you're looking at, and that way you'll be able to make an informed decision if this is a model that you would like to try to build. One last thing to note, as shown, it weighs 25.6 pounds, little over 11 kilos. There is plenty of room to put more weight in the back here. I could probably add another 3 pounds, but what I found, since it's an articulated machine, if you add a whole bunch of weight hanging over the rear end, obviously that lifts up on the front end and really negatively affects traction for the front tires. So I could make it heavier. I've jammed in just about all of the weight that I can up in the front. There's room in the back, but again, I found that it would kind of counteract. It was really not beneficial. So you're adding weight but decreasing performance. So 25 is a good number with steel weights. I know some people are enthusiastic about lead and more willing to work with it than I am. You could probably easily get over 30 pounds if you're going to use lead. There's roughly 8 to 10 pounds of steel weight added to it, and I'll show you where those are at throughout the process of putting it together. All right, we'll be right back. And it is time to start on assembly. Before I do, I did not disassemble my wheels on the finished model that I just showed you because they are glued together. So instead, I'm going to start off by showing you the basic wheel assembly. The wheels that I chose to make have some metal-filled PLA that you're able to rust, and I'll show you those in a minute. This is one of the prototype wheels I printed with just plain PLA, so I'm going to show you the assembly. It's the same for all 4 wheels. All 4 of them are the same. They're all interchangeable. There's no left, right, front, back. All 4 of them are the same. They're pretty easy to build. You've got your middle. I only printed these at about 50% infill. In retrospect, if I was doing it again, I'd probably print them at 100 just because the weight gained would be nice. It would be nice to have a little bit more weight in the wheels. So if I were starting today and had the patience and the filament, I would print these at 100%. Having said that, they're super strong at 45 or 50%, but again, the added weight would be nice. So each wheel, you've got the center hub, which has a large bearing pressed in the back of it, and this should just press and snap in, get it on a flat surface, push it in there. So that's your bearing in the back that will ride on the axle. We'll look at that here in a little bit, but gives some support and makes it so that the motor output shaft isn't carrying all the load of this giant wheel, so it's a reinforcement to keep it stable. And then you've got 5 rings. The rings are lettered A, B, C, and D. Hopefully you can see that in there. I'll zoom in at this point. So with the wheel face up, bearing side down, we'll start with A, and we slide from the front back because pretty much every printer is going to leave a little elephant's foot around the back here, which is going to make it difficult to slide this on unless you start from the front. So if your printer settings are tuned in, it should be a pretty nice little slip fit. There are 3 asymmetric ribs. Those ribs are what engage and drive these dog sections. And so you've got to line those 3 ribs up, and if it doesn't line up at first, you'll just have to keep clocking it and spinning it. But once you get started, it should slide right on. You want the backside flush with the back of the wheel, so I usually slide it on, make sure it fits, slide it forward a little bit, and then I just put like 3 small dabs of super glue. It doesn't take much to retain it, and then I slid it back and locked it on, and that worked really well for the rusted ones too that I'll show you here in a minute. And you just continue. A and B are the first 2. They will be like this with the dogs or the drive ears towards the back, and then the flat hoop section up. Then when you get to the middle, you'll have C, which has no hoop section on it. And then above that, D and E will flip around so that the ears are out and the hoop section is down. And the very last one, E, is a little bit unique in that these drive ears do not extend all the way out, so you don't have an ugly groove out here at the face of the wheel that you've seen. So you'll see that the drive slots or the drive tabs end just a little bit short. So this last one will locate itself, and when it slides on, it will actually stop at the right depth. And there should be just a tiny, about 1/2 millimeter of rim sticking out past the face of these drive ears, and that's to replicate the real wheel that has just a little bit of flange sticking out. So that's how you build a wheel. Again, all 4 of them are the same. Irregardless of whether you build it all with PLA or if you choose to do the rusty look, the assembly is going to be the same. With these, I'll talk about these for just a minute. I was able to use some Protopasta iron-filled magnetic PLA. It's quite a bit more expensive than regular PLA, but it has the really nice added benefit. 1, it's heavy. It's denser than PLA, about 130% is dense, so it adds a little bit of weight. And 2, you're able to chemically rust them or patina them. So these were soaked overnight. Each one was soaked overnight in a solution of 3% hydrogen peroxide and some vinegar and some regular table salt, just submerged in a bucket. Because the rust adds some roughness and dimension, I did assemble the wheels first. I put all the Protopasta PLA sections on to the regular PLA hub and then rusted it all at once. Obviously the regular PLA completely unaffected by the rust solution. Doesn't even really stain it as long as you get it cleaned up right away. So this way you could do a body color if you're going to do a white or gray or yellow machine, and then simulate the rusted metal on the wheels, and it gives them, I think, a really neat look. Again, completely optional. You could certainly just do body color PLA for these as well. We'll set that aside. So let's talk about the front of the body. So this is our main chassis. It is really just one piece here with two little ears, two little spacers added on that these screws are holding on. The only reason that those aren't incorporated all together is because this will just fit on bamboo carbon X1 or another 256 millimeter printer. So it's 254 millimeters wide right here at the widest point. It will barely fit on an X1 carbon, but it will fit because of these extended ears. So the front section here, very straightforward. We have a 35 kilogram servo mounted inside. There's 4 mounting screws that hold that down. A 25 kilogram would probably work, but the price difference is like $3 on Amazon. Unless you just have a bunch of them laying around, I don't think it makes sense to skimp on that. I used the metal control horn that came with that servo. Again, the link to the exact servo I used, an Amazon USA link, will be in the bill of materials. Threaded rod here, I used some 4mm turnbuckles. Yours may vary slightly by length, but I made myself a note here. A very good starting point for length from eye to eye is 52 millimeters. So that's a really good starting point there. Underneath here you can see that I have packed this pretty much as full as I can with these wheel weights. I'll leave a link to these if they're USA. If you are a USA builder. Overseas, I realize you may have to source other weights that are slightly different, but I really like these steel wheel weights. I think there's about 8 or 9 pounds worth of them in the machine. I was just able to cram a few more in the front here that I didn't have in the prototype, so I think now I've got the weight just over 26 pounds, so I'm really happy with that. And then the other thing to note, you've got 2 M4, and let me measure how long these are. So you've got a length M4 by 12 button-headed cap screws. You'll see here in just a minute that those attach to either side. The screws come in and they grab the linear actuator that runs the front blade up and down. But that's really it for this piece. 1 servo, 1 rod, a couple screws here, and a whole bunch of weights everywhere that they can fit. And then 1 M2.5. The only place on the machine I used M2.5 is here for the track bar up front that keeps the blade centered side to side, just because it looked a lot better with the smaller threaded rod and the smaller ball end linkages. You could certainly use 3mm. It's just going to be bulkier and heavier looking up there. The front motor assembly I have all together, and honestly I didn't want to take it apart, so instead I'm going to show you a back prototype one. The assembly of these is very straightforward. You basically have 2 motors, 2 end caps, and a center section. I've got the motors wired up again just in parallel here, so I've got a plus and a minus. I could have done it in parallel here within the housing and only ran 2 wires out. In retrospect, maybe that would have been better, but initially when I was prototyping I didn't think that far ahead. Really very straightforward. So you have a center section. This is the back, not the front, but I think you get the idea. It's very similar. You've got caps that the motors go into. You'll put all of the bolts in the motor face here. Some M3 button-headed. It's important to use button-head so that there is clearance behind the wheel, so that these don't rub on the back of the wheel. So use button-head bolts for this. And then screw this together, self-tapping screws from behind. I think these are 12mm, 3mm self-tappings. Screw that all together and you've got yourself an axle. So again, the front axle here, the center section is different, but it's essentially the same thing. Then the wheels will mount with some 8mm flanges out on their ends. We'll look at that here in a little bit, but that gives you an idea of what it takes to build an axle, which is to say not very much. You can put an axle together in just a few minutes. Again, I used 90 RPM motors. In retrospect, if I was starting over, 50 or 60 RPM motors would likely be more appropriate. That's going to be your preference. How fast do you want the model to be? But really, it doesn't need the amount of speed that it's got with the 90mm motors. And so less speed and more torque would probably be a pretty good option, and probably one that I should have pursued, but again, all these things I learned as I built it. So the front axle goes in here super straightforward. It's going to take me just a minute to get this wiring through, so I think there'll be a brief break and a brief edit here while I fight with this, and then I'll show you how it all bolts in. To snake the motor wires through, I didn't leave myself much room with all the weights I put in there. So you can see the front axle just simply drops in here, slots right into place. Some 15mm long M3 screws. Again, I'll probably edit this here so you don't have to watch me screw in every single one of these. I feel like you know how a screw goes in. and probably don't need to watch every single one get driven. Okay, those are in. Next, we've got this front lower plate that's part of the pivot. Again, some more weights here so that they kind of fill this cavity underneath. This screws down. Looks like these are 8mm long. Most of the screw lengths here are going to be pretty tolerant. I made all the holes longer than they really need to be, you guys, for just about everything. I don't have some kind of printed guide or amazing instruction book that's going to show you every single length of every single screw and every single hole. I feel like you can figure that out. Buy yourself a nice M3 self-tapping assortment and regular assortment, and you'll be good to go. There's more than enough screws in one of those $20 Amazon assortments to build this whole model, and then some. Probably almost build 2 of them in most cases. So I think you'll figure that out as you go, but I'll call out some of the lengths here as we go where it's super obvious, just to give you an idea of what you need. So we're close. I mean, the front end's close. Next, we're going to attach these scrapers. Again, I'll probably show you you can see they're nice and dirty. I've been using them and they do actually work. Probably talk to you through the first one here and then fast forward through all the rest. It's pretty repetitive. Again, with any of these, you're putting self-tapping screws in PLA. As you can see, I'm taking it super easy. This particular screw gun doesn't have a torque setting on it, but ideally that would be even better. I'm just using some good trigger discipline here, taking it nice and easy. Okay, there's one. We'll zap through the other 3 here. Okay, all the screws are in, including the one I dropped on the floor and had to retrieve. So you can see the front end here. We're getting pretty close. It is actually close to done. We're going to attach the blade now. I'll show you the blade first. Again, my blade is mostly assembled here, but I'm going to walk you through what's involved. It's pretty straightforward. We've got the linear actuator. The one I spec out has a nice black body. It costs a couple dollars more, but it's got a nice black body, so it looks more like a hydraulic cylinder. You've got the extension. In real life, the hydraulic cylinder is a mid-mounted cylinder and has quite a bit of body above and below the mounting point. I've tried to replicate that. We've got 2 arms, button head screws holding them together. The ends have got, again, M3 hole ball joints here that mount it. Pretty straightforward, pretty simple stuff. The blade arm is just 3mm threaded rod. You could get smooth rod and cut the ends with a die to to make it look a little bit better, or you could slip a piece of brass tubing over it and paint it yellow. That'd look really nice too, or just paint it yellow if you want. I didn't paint my model, it's all just raw PLA, but if you're painting the model, certainly you could use some paint and paint that and make it look a little better. The blade cylinders, simulated cylinders, are actually 10th scale shocks, RC crawler shocks, and I put the stiffest spring in them. They come in a kit. You get 4 of them for about 21 bucks. You only need 2 for the model. They come with 3 different weights of springs. I put the stiffest spring in them, and they're quite stiff. You could also make a brass or plastic spacer inside and completely lock them out. Obviously, if those move, the blade is going to rack side to side like it would on a real machine. In practice, I've found as I'm pushing dirt, the machine doesn't really have enough power, enough traction, it's traction limited, to overcome these, and so it hasn't been a problem yet. Should it be a problem, I'll further lock them out, but I figure it gives just a little bit of safety buffer, so I left them in place. So to mount this, pretty straightforward. Take our M2.5 wrench here, and we'll mount this from both sides. Really pretty simple. Again, none of these techniques are overly complicated. You can see we've almost got the front end built in, what's it been here, not even 10 minutes probably, and we've got the front end almost built. My particular brass ball joints here are just ever so slightly tight on these M3 screws. I should have reamed those out off camera, but instead you're getting to watch me fight with it here as I force it through. There we go. Put our spacer on there. These are printed, so they're just a little bit tight too. I think these M3 self-tappers are more like 3.1 millimeters in diameter, so even after I've ran a 3 millimeter reamer through them, they're still just ever so slightly tight. Again, I think I mentioned it earlier when I was talking about the reamers, or when I was talking about tools in the very beginning, but I make extensive use of these reamers. So super cheap set, they're like 22 bucks on Amazon. Really a big fan of them. All of my models that I design, I always ream the outer hole for clearance, and then obviously whatever it's bolting to is tighter, like 2.4 millimeters, to allow the screw to attach. But if you don't have a set of these already, consider buying them. They're really nice for 3D printed things, since 3D printed holes always tend to be just slightly smaller than you spec them out. Even though I've drawn these oversized for clearance, all the 3 millimeter holes are drawn at 3.1 if they're meant to be a clearance hole, but still, especially for things that print down on the plate, that elephant's foot comes into play, and you end up with a hole that gets slightly swollen shut. So those reamers are just super nice for that. They're really helpful. Okay, got both sides of the blade attached. I find it helpful and handy to do the track bar or the sway bar here next before the cylinder, because it will allow us access. Get this attached. Again, these are M2.5 screws as designed here, the only place on the model with those smaller M2.5s. Okay, we've got that. Now we'll attach the blade back to 2.5 millimeter here for the button-headed cap screws. These are 4 millimeter button-headed cap screws, and they just perfectly come together and meet in the middle, and they'll capture our elevation cylinder here that raises and lowers our blade, this little linear actuator that simulates the cylinder. Okay, our front end is substantially done. The only piece left is this cover. I designed this cover to be glued on. I found in practice that it is actually a nice friction fit, and I just left it that way, and I'm kind of glad that I did. So far it hasn't tried to fall off or come loose or anything like that, but it makes it a lot easier to work on the model, simply because you can get to all of this wiring if you want to and take things back apart, which is proving to be very useful now to make this video. Hopefully once you build your model you don't really need to work on it much, but we'll pull those wires through. Again, this just snaps in place, and I found it to fit really well. I put 2 little zip ties here. Sometimes I put new wires on the linear actuators to get rid of this red, because I really don't like the red. In this particular case, I'm able to bundle it with zip ties, and on the real machine you've got a bundle of hydraulic hoses that go here, so I won't do it on camera now, but I put 2 zip ties, one here and one back here where you can't see it. You end up with a nice little bundle. And then there's a hole for this to come through, in the middle of the chassis and you really don't see it either, so the servo wire doesn't bother me much. You could put some heat shrink on it or something too to make it look more like a sleeve on hydraulic hoses. So okay, that's it. In a few minutes, granted we didn't build the wheels on camera and so it's a bit of a cheat, but once you've got the wheels built, you can see that really you can build the front half of this machine in no time at all. The back's a little bit more complicated, but not terribly much so. I'm going to set this aside, do another cut. I'll get some parts and pieces on the bench for the rear end and move to the back of the machine. So you'll have to bear with me a little bit. There are actually 7 pieces here, 8. I see there's an 8th piece bolted on. I'm going to cover with you pretty clearly what those pieces are, but since there's some glue involved here and a whole lot of weights, I've got it as kind of torn down as I was able to, but I'm going to walk you through what we're looking at and I think it'll make perfect sense. So the rear chassis is 2 main pieces. We've got this rear tray, which is 1 print, and then the middle, the bulk of the machine here, which is another big print. Bolted onto that, we have a little removable mount for the slewing servo, the servo that steers it. I made this bolt on. It's plenty sturdy. I haven't had any problems with it, but if and when it does break, somebody kicks the machine or does something crazy or it tips over and this does break, I didn't want it to compromise this whole 12-hour print of a rear chassis, so it's like a 10-minute print. It holds on with 2 screws. So I think if anything breaks, it'll be these ears. 10-minute print to fix it. Maybe print yourself a spare while you're at it and throw it in your toolbox for when you go to the RC park and play. And then these 2 parts are bolted on. The only reason I didn't take them off is because it's quite a bit of ball driver work down in here. 3 M3 screws, self-tappers to mount each one, and I was just simply too lazy to take them out. I think you can figure it out. There's a left and a right. They really only fit one way. They're keyed in there, angle to make room for the wheel. I think it'll make perfect sense when you go to bolt it together. As far as bolting this on, we've got 6 bolts here. They're pretty long, like 25s, I think. You'll see when you print it, again, like I said earlier, it's pretty obvious what length bolts you can use where. These holes go all the way through from the bottom, so you could even use like a 35mm bolt or screw if you wanted to and run it all the way up. You can see I've got the whole back here filled with those wheel weights. They happen to fit really perfectly. There's plenty of room here, and I could have stacked like another pound of them, which would add to machine overall weight. But as I alluded to earlier, spoke about earlier, you've got this cantilever effect with the rear axle here. So as I hang more and more weight out of the back, it ends up picking up on the middle of the machine, which is nice. It takes stress off the middle of the machine. But when you add too much, and we're basically right at balanced here, almost perfectly balanced. If I'd add any more weight back here beyond what the printed parts, the hood and the radiator add, and of course the battery, then we're really taking away from traction up front. So I didn't want to add any more. You certainly could. It's just going to be at the expense of traction. Talked about it earlier, but there's a snap-in panel-mounted power switch here. There's the XT60. If you don't use XT60, first of all, you should, but if you don't, if you like some other battery connector, that's okay. You might have to Dremel this out and get a panel mount of your own, like if you use the blue or the orange ECs or something like that, then you might have to adapt this or make yourself a little, just a little closed adapter here that would adapt from the XT60 to whatever your battery of choice is. Got an ESC here for the front drive motors. This ESC goes down to the rear drive motors. I think I'm actually, when we're done making this video, or I'm done making the video, I might move this back about an inch, 25mm, and I may put another stack of weight here since it is just ahead of that axle. It's still in the midsection, but it would give me a little bit more downward pressure on the front. So I think I may do that as well. These simulated tread piece, or these simulated knobby plates, are printed flat on a smooth build plate, and then they are glued. There are some very shallow 0.5mm deep recesses that help you locate them. It's the same here and for the mid and the forward platform. Similar technique used for all of them. They just glue on. So on the real machine, most of these are honestly yellow. They tend to get worn off and end up being rusty metal as I look at pictures. I saw one machine somewhere in photos where they had applied some black tread compound to them, and I really like the look. I like the contrast it gives with the black and yellow, so I elected to model all of mine in black although it may not be incredibly prototypical, but it's my preference. It looks better. There's quite a bit more weight down inside of here. I think you can just see them peeking out. So when this rear section's off, there's a hollow area in there that you can slip the weights into as you're building it. Pretty straightforward. And actually this mid plate here that all the electronics are on, I forgot to mention, is a separate printed plate that goes in here. So there's actually pretty easy access to add weight in this area and then in this area, which is under that plate. So this whole area is filled with those weights as well. Just keep them below the layer of the plate. It will be obvious because there's rails that plate mounts to with some screws, and then more weight on top, and again more weight back here. This is the circuit breaker I talked about earlier. Big fan of these, super cheap. There'll be a link in the description. I think you get an assortment of like 5 or 6 of them for $15, so it works out to about $3 a piece, super cheap. The rear steps glue on. I didn't glue those on until close to the end because they are somewhat prone to getting snapped off, and so you have to be careful. And then I'm a fan of these Wagos. I glue Wagos in and basically use them as junction blocks. I've got my negative bus and my positive bus that I use to power all of the electronic speed controls. You can wire things however you see fit, obviously. And then buried down in here, somewhere hiding, I have a very small electronic speed control that runs to the to that front linear actuator through this two-pin plug that powers that front linear actuator for the blade up and down. So that is the midsection. We'll go ahead and put the rear axle in it here if I can get things to balance. Rear axle is held in with a bolt. Needs to start off as this, a M5 bunk bed bolt that I will spec out in the descriptions. You could also get a different bolt from a hardware store, but I like these because they have this smooth section for the bearings to ride on. You could see that it just ends right past the bearing housing there. So I like the bearings riding on a smooth shoulder rather than on threads. In practice, it probably really doesn't matter for this model. A regular 65mm long bolt from the hardware store would probably work just fine. But I like these for their smooth shoulder and the fact that they have this big truss head on them that has some nice support. So it'll start off as one of these longer bunk bed bolts. I think they're like 100mm long, 90 or 100mm long. It's a pretty simple hacksaw job to cut it down and then file the end of it. But again, you could choose just a regular bolt if you wanted to. See how lucky I am here if I can get these wires to feed through. Of course, everything is 3 times harder when you're on camera, if you didn't know. Pressure's on to not screw this up. Okay, I've got those fed through. And we'll put this bolt in. Should slide all the way through and then tighten up here at the end. Let's talk about this rear axle for just a minute. The only real difference between the rear axle and the front axle is again the fact that this one obviously has a pivot that runs through the center section. That's the most noticeable difference. But this one, rather than having, I'll find it again here wherever I set it aside, rather than having smooth caps like the front wheels, this has caps that also incorporate arms that come out to the scraper bars. So that's how you know the front from the back. The fronts look like this, just a round top hat looking deal. And the rear ones have got arms. They're symmetrical side to side. I tried to keep everything as symmetrical as possible. There's no difference left to right. They are the same. And you can see those scrapers do a nice job of cleaning the wheels both directions as you turn them. That shows the articulation of the rear wheels. It hits on the body here. And so that's the limiting factor. The stops are kind of built in, if you will. With that, I think we've got the foundation of our rear end built here. We're going to start adding some details. Okay, a quick note on the rear wheel here. The only place in this entire model that I have American or SAE standard screws that aren't metric are here on the rear wheels. Unlike most Americans, I fit many of the stereotypes about Americans, but I do like the metric system and have embraced it and prefer it actually. But I'll tell you why these are standard 632 bolts. Number 6 bolts, 32 threads per inch, if you don't know what that means. The 8mm axle flange adapters that go onto the electric motors happen to have a hole in them that is the perfect size to accept a 632 tap and therefore a 632 screw. You could drill or remount the wheels to 4mm and then drill out the wheel flanges to the appropriate size to tap for 4mm, something like 3.2mm hole, so that you could tap a 4mm thread if you wanted to, but I wanted to make it as non-machinist friendly. Some people aren't comfortable at all drilling and modifying metal parts. So if you want to go that route, great, I don't see any harm, but if not, if you'll just source 16 632 bolts, you'll be able to attach your tires right on. I thought these were going to need glued on. They actually end up snapping in there quite nicely and so far have stayed put. Maybe a little glue will be necessary at some point, but so far I've found that they just snap in and fit really well. Shout out to the camera you're watching right now, Insta360. It turns out that the box for it is the perfect height to set this on and build the rest of the model. So good use for a box that I saved for seemingly no reason whatsoever, but here we are. 2 platforms are next. These are comprised of 3 pieces. We've got the support, the platform, and then the tread plate that's glued on, held in with some little 6mm thick screws, or 6mm long screws I should say, sorry. And pretty straightforward. I might put about 1 bolt in here while I talk and then fast forward once again so you don't have to watch me screw in a bunch of bolts. Okay, that wasn't so bad. 6 bolts in place. We've got those 2 platforms attached. One note about these platforms, mine are already screwed together. I would definitely recommend that when you put yours on, you have the cab sitting in place. We aren't to that point yet, but when you glue these together, have the cab in place, because the cab just fits down in between these, and I wouldn't want you to get these glued a millimeter off maybe and have the cab not fit. Ask me how I know. It might be a little tricky to pop these off and start over. Again, ask me how I know. So have your cab in place. The cab slides in with a tang, I'll show you that in a minute, and bolts with 2 M3 self-tappers underneath, but it will help gauge the width of these. Rear steps here are comprised of several pieces. So we've got 2 halves, kind of J-shaped halves. We've got 8 stair treads that are printed. In this case, I printed on a textured bed because it gave a nice little texture to them. I actually didn't like the way the treads looked when I printed them on my smooth plate, so I went back to my old textured plate to give them that little bit of grip. And the reason for that is since they are L-shaped, they pretty much need to print upside down, so I couldn't do the same coin pattern on there. It would have required a ridiculous amount of supports to print those, and it didn't seem to make sense. So went for the textured look instead. 4 bolts holding together the 2 halves and this tank that goes behind the cab. It's got a slot in it that will receive the cab. I'll show you that in a minute. We've got 2, I think these are 10mm long button-headed 3mm screws. It's important that they be button-headed because that tang for the cab needs to slide in here. And if you use regular screws, they'll be in the way of that tang. So if you use button-headed screws, they'll be recessed down in. And then these are, let's measure these so that I don't tell you the wrong length. I think they're 25mm, but they might be 30. Yep, 25mm long. There are 4 25mm long screws that come up from underneath from these 4 holes, and they'll come up and they will go in the bottom of the stairs. To be honest with you, they really aren't necessary. Once you bolt this on, I don't know that I'm even going to go through the struggle of putting them in there, but they do hold this all down, and they do mount it nicely. So they're modeled in there. You should probably use them, but again, I don't know that it's going to be 100% necessary to put them all in. But if you're the kind of person that likes a screw in every hole, then you'll want to put those 4 screws in, certainly. We'll get these 2 screws driven and get this bolted down. We're getting closer here. Again, you can see this really goes together pretty quick. Granted, I've kind of glossed over the electronics part, which is going to take you a little while. And building the wheels off camera really helps, but I think you can probably build and wire this model in a couple of fairly relaxed evenings at home, or in one weekend without it being too stressful of a deal. The grill. Let's put the grill on next. So the grill also doubles as a support for the battery tray. We're going to put that on in a minute. So it has some support features built into it for the battery. Mine happens to have black foam tape in it. Ignore that and don't do that. I thought it'd be a really slick thing to put this nice foam neoprene tape in there. As I mentioned earlier, my silly self, even though I designed it with barely any clearance between the ultrasonic water tank and the battery, I didn't take that into account when I stuck this black tape in. I subsequently had to peel it out because it was causing the hood to set about 1 millimeter too high and leave a gap. So don't do that. Don't be that guy. We've got 1 screw that comes from underneath that's going to go into the grill. I'll probably do that off camera. And then we have 4 shorter 15 millimeter screws. This has some features in it here which will lock it around the hitch area, give it some support. For these, a ball driver is really slick. You could probably do it with a straight driver, but a ball driver is pretty handy. It works fine with a straight driver, but if you've got a ball driver, probably use it. But I don't know, the straight one's working just as well, so no real issues there. This next step will definitely necessitate a ball driver because it is just too tricky to do with a straight driver without tearing up the heads of these screws. Okay, battery tray. Again, ignore the ugly black foam tape that's been peeled out. You won't make that mistake. I've done it for you, so we'll just consider that just between the two of us, okay? Your tray is going to look just like this, ever so slightly different. It's going to have a recess here where everything bolts together. Since this was the prototype, these are actually 2 separate pieces. I've simplified that in the final version that you'll print, so your mounting tang right here will be ever so slightly different, but really the same in the end. This has a feature that fits around that battery support in the grill. I realize it's mostly out of frame right now and you won't be able to see it. I'll turn this sideways to try to give you some kind of view, and hopefully at this point I'm zooming in that camera and making it so you can see. We've got 3 places here for bolts, and this is where you're really going to need a ball driver because you aren't going to get these in if you have a regular driver. Use nice short bolts. I think these are 8 millimeter long screws. Sorry, I say screws and bolts interchangeably. I realize there's a difference, semantics though. Use nice short ones so that you don't have pokey heads coming through wanting to rupture your beautiful LiPo battery that you're about to put in this tray. All right, and then in my case, I've got some little tiny M1.5 screws here. Again, yours will be just a little bit different because of the way I've redesigned it. You're smart. I think you'll figure out that part when you get to it. It all just kind of fits together almost like Legos. And then again, your 5000 or your 5200 amp battery is going to fit in here real nice. It's going to plug into that onboard XT60. Got some room here for your balancing connector to lay, and that pretty much finishes up this area. Let's grab the hood and look at that. I've got a couple things to talk about here. So with the hood, we have some small magnets here. Again, I've used the same 3 millimeter diameter, 2 millimeter thickness magnets. There's a bunch of them stuck here. These will be spec'd out in the bill of materials. Those are used everywhere throughout the build. So if you see a magnet going somewhere, it is the same. We've got 3 pieces here glued in that are just black backing pieces that go behind the grills. The grills are printed separately and then inserted in here. The reason being, this prints like this vertically as a big piece, and those grills would have turned out like crap if I tried to make them all integral. So they are separate pieces that snap right in there with the black backing to give them the hopefully the illusion of some depth there. And then the intake breather just held on with one 3mm self tapper, so super simple there. We've got 4 magnets pressed into 4 holes, and then I put just a dab of super glue on the back of those 4 since they're an open hole to the back. They're not a blind hole you can get to the back of them, so I put a little dab of super glue to help retain those magnets, and those again hold the exhaust stack on. A couple of reasons for that. One, it makes it less fragile, but the real main reason is that I'll show you in a second. This is the way that we're going to fill the ultrasonic tank. This next part is completely optional. Let's look at that ultrasonic tank. So if you don't want water mixed with your electronics, you don't want a model that puts out white smoke, I realize it's not as realistic as some sooty black smoke would be, or you're just not interested in smoke at all, then you can skip this part. You can ignore it. It's completely optional. You don't need it. The model will be the same. You just put your exhaust stack on and no one will ever know the difference. If you do, however, want a model that puts out a white vapor or white simulated smoke, I like it because it doesn't stink. I can run it in my garage here, can run it in the house. There's no stink. It's just literally an ultrasonic humidifier. So this is a USB or a 5-volt powered ultrasonic humidifier. This is the driver board for it. This is the emitter head. And then this yellow part is a printed tank that you'll make on your printer. It's just held in with 2 self-tapping screws. It will fit right up, and I've got some bosses or some features there that it will bolt right into. There is just a little bit of gap between this and the top of the body. That's definitely intentional. You get a Venturi or an induced flow effect. If this was tight against the top of the model, you only get about half of the smoke output, but with that little gap, it's just over a millimeter and a half. It's intentional. Twofold. Makes room for the wires to come out, and then again it allows that induced flow that really pretty nearly doubles the volume of the smoke effect. So that's the reason for that. If you notice a gap, it is definitely intentional. Don't seal it up or you'll see reduced smoke output. This is held to the top with Velcro. I will tell you that the way I have this set up right now, it requires you to press the on button. Once you've powered the model up, this would be hooked up here to get my power. Once you power the model up, you have to push this to turn the smoke on. Now there is a spot on the circuit board that you can solder a RC switch to. I've done that in my other models that I've added this similar smoke feature to, and I intend to do it here. But for simplicity's sake, and since those are pretty specific customizations that are going to depend on which RC switch you choose, you really need one that's relay based because you're basically closing a contact here. So you need an RC switch that has a relay output that just closes, not a voltage output. So you'll see on the back of the board under this Velcro there are 2 solder pads that you can use if that's something that that you want to try. So we're going to cut here. I'll have this screwed back in the model and I'll show you. Okay, I've got the ultrasonic tank attached. It is hooked up here underneath. You can see that I've also mounted the drive unit, the ultrasonic amplifier, the driver that actually vibrates the ultrasonic disc there. And if you look on top here, you'll see that it is recessed down in there like I had mentioned earlier. That's intentional to allow for that draft. When you want to fill this, you simply take a cup of water and a little pipette or a little eyedropper like this, and you just fill it up in the middle, and it will overflow past that disc. It'll leak past that disc around the housing for that disc, and it will fill up that reservoir. I put like 6 or 8 pumps in here. Obviously you don't want to overflow it and get water down in your battery tray. Not that it would be the end of the world, but wouldn't be good if it got on the speed controller, I suppose. And then I take a little suck right here at the end and just suck that little bit out that sits on top of that piezo disc, because if you have a big puddle on the ultrasonic piezo disc when you try to start it, it won't be able to rupture through it and make that mist, and you'll just kind of get bubbles and not much. So that's about it. And then keep this fairly level when you put it on and off. There's some tolerance in the tank, you know, it won't slosh out of the top, but if you tip this thing way crazy sideways, water's going to come out of it. It's again not the end of the world, but you don't want water dumping on your electronics. And then you just hold the exhaust on with the magnets. So there's our rear hood, ready to drop on and ready to install. You can see it's held in by magnets. It sits here along the front, so that's really all that there is to that. I'm going to slip it back off now just so it's out of the way as I assemble these last few parts, but you get the idea. So time to marry the two halves together. We've got the back half that we just finished, the front half that we built a little bit earlier. M8 bolts. These happen to be M8 by 1.25. They could be the other pitch too, the finer pitch, it doesn't matter. 25 millimeters long, 20 millimeters long. The longer one, the 25 millimeters, will go in the bottom. I find the easiest way to do this is to slip the two halves together and get that bolt in there. We can turn it sideways for that. We'll get this bolt started in here if I can get my fat sausage fingers in here, and then I put the Allen wrench down through the top hole so that I can drive it straight on. Again, of course, this is proving to be more difficult because I'm filming myself, so naturally it's going to be tougher. And we'll just thread that down through all the way until it comes out of the bottom. I use these button-headed screws. They just look better than a regular Allen screw would, but certainly you could use a regular screw if you wanted. Must be slightly off on my alignment there. It started to press the two halves together, and I don't want that. I think for this part I'll take the box out from under it so I can get it lined up. There we go, finally getting it down through the middle. Trying to get all three of those plates to line up when they fit so closely can be a little tricky, but obviously we don't want too much clearance there or she'll be floppy in the middle. And then we'll do the top screw here. So for this I reamed the top and let the bottom one cut threads in the plastic, so the first time you put it in, obviously it'll be pretty tight, but then after that it gets easier. So this has been together a couple times, that makes life a little easier. Alright, we're going to route all of our cables under here. Again, like I mentioned earlier, put a zip tie here, a zip tie up here so that it looks like a bundle of hydraulic hoses. Servo cable will route through this hole down here, or if you prefer you can route it up above. It actually won't get pinched because the rotation is limited before the wires would get pinched, so you can also bring it up here in this same bundle. Alright, to do this next part I slide it towards the edge of the bench and I use my ball driver. Take the screw out of the mount here, and I needed to grab the 2mm ball driver rather than the 2.5. Take the screw out of our mount, and you probably won't be able to see it, but I'm just putting that linkage that we had made earlier through, and we'll get the screw in place here. Hopefully at this point I will have zoomed in so you can at least see I'm putting a screw in the bottom. One of the nice things about this camera is that in editing afterwards you can focus on whatever you want to focus on. Okay, I've got the screw in the middle, two halves are joined together, servo's hooked up. really all that's left now is detail parts, namely the cab. For the interest of this video, I'm simply going to tuck all these wires in. Obviously, I need to make my connections and actually hook things up, but you don't need to see me do that. Your setup is going to be slightly different than mine, and I'm actually able to pry these two weights apart just a little bit, and I have a channel underneath where all the wires run. Underneath this plate of weights, I've got a hollow spot, so I'll run all my wires through there, but I think we can make it work for the sake of the video. Let's look at the cab. So the cab is just a few pieces here joined together, and again, since it's glued, I can only take it apart so far. So you've got the main cab, which is one big print, this HVAC unit, which is attached on the side. I made it a separate print just to make things easier. There are two screws that come through the side of the cab and join that, and then from the bottom we will attach the bottom the floor, if you will. It's got a couple holes in it to allow you to get your wiring out should you choose to add lights and a beacon. It's got a path there, and then you'll need 4 or 6 super tiny screws, and actually it snaps and fits. You might not even have to have screws, but it'll hold the cab on better if you put some super tiny screws here holding the bottom on. And then inside you'll see there's a seat, a left and a right console, and a front console, and those all glue. They set down in some little pockets that are real obvious in the floor, and they glue. The lights are a challenge, I'm not going to lie to you. Wiring these up and getting them all routed nice and tidy. I used some UV glue, soldered everything together here, put it in this heat shrink. But you don't want that stuff all hanging down in your cabin looking terrible, so getting it in these channels is a pesky little job, but you could do it if you're patient and take your time. And then there's some grooves here and some tabs on the cab of the roof of the cab, I should say, and so that'll glue on. I'm not going to glue it here on the video, but the roof will glue on. Got your beacon and your 4 lights, and those will all come out the bottom. And then I've got a couple harnesses that I plug up right here and put her together. The mirrors, once again, attach with magnets, so real simple. Mirrors on and off. Pretty easy. And then the cab, to install it, you've got this tang along the back, and it slides in a groove here underneath this tank. It'll just slide in that groove. Hopefully I can get my wires enough out of the way here. It'll slide in that groove and it'll drop down, and then you've got a spot for 2 screws, one on each side, so you can take your ball driver once again, put a couple of self-tappers up in there, and that holds the whole cab on. So if you need to get to your electronics within about 5 minutes, you can take the cab off, undo your plugs if you put quick disconnects on there, get it all unplugged, and be able to get to your parts and service them pretty quickly. The handrails, I've already shown you if you've watched any of the driving videos or some of the previews I put on Facebook earlier on. But the railings all feature those same 3mm magnets embedded in them. I resin printed these railings because you get a dramatically better result with the resin print than you're going to with FDM. I did FDM print a set just to make sure that it could be done, and it can. They're just not going to be very strong because they're only 3mm, and when the printer stacks all those layers up, you've got hundreds of little weak points where they want to break. So resin, if it's an option for you, or if you're maybe able to send these out to one of the printing services, it shouldn't be too expensive to get those resin printed, and those will just attach right there. So just kind of mock it all up for you here so we get a kind of a final parting view. Helps if I turn it the right direction. But hood drops down, get all my wires tucked in here. Hood tucks in, obviously the roof will be glued on so it won't be loose. We'll have our other mirror attached here. The little hangy downy goes down low, that's how you know left from right. Get our railings all hooked up here. And other than some wiring, I need to take this back apart and do some wiring obviously, but other than that, there it is, put together. Again, I think in a couple evenings, if you've got everything printed and all your parts are made and ready, you should be able to build it in a couple evenings without too much trouble. Wiring's pretty straightforward, no special mixing on the remote. Everything is just really pretty straightforward actually. So I hope you enjoy building it. If you've got any questions or problems, please reach out in the Facebook page. I've got that Capital Customs group where I'll try to be active answering questions, and then other people who have maybe built the model or have some experience with it might be able to help you as well. But I think if you've built any of the models by the other builders that are so common out there, the guys that have been doing this quite a while, a lot of the techniques are shared, and I think I've spent quite a bit of time making sure the parts fit and that things will work. So your frustration should be minimized. Things should go together, and you should be able to make one that looks just like this without really any super skills or exotic techniques or any kind of machinery other than the one bolt you're going to need to cut with a hacksaw and those 16 holes that you'll need to tap. But beyond that, it's all printing and screwing and gluing things together and doing some wiring afterwards. So thanks for hanging with me and watching this whole long video, listening to me ramble. I hope that you like the model and that it's something you might be interested in potentially building someday. Post up your pictures if you get one built. It's always fun to see something that you designed, and people undoubtedly customize things a little bit, change colors, maybe put their own little spin on it, and it's always kind of fun to see what people come up with.